Okay, got to find the stationary points on this graph and sketch it. So part A, stationary points, I need to differentiate it and then set it equal to 0 and solve that equation. So I need to differentiate it to get dy by dx, the gradient function. That'll be 12, 2 times 3 is 6, that'll be plus 6x to the power of 1, and then minus 6x, and that'll decrease squared. And for stationary points, so stationary points, 12 plus 6x minus 6x squared equals 0. But I'm trying to put the other way around, I'll change the sign as well. 6x squared minus 6x minus 12 equals 0. Divide through by 6, so x squared minus x minus 2 equals 0. And this looks like it'll factorise. X and x get x squared, got to get 2, so it's got to be 1 and 2, put 1 and 2 in. And it's a minus 2, so one's positive and one's negative, and we want minus x, so it's going to have to be the minus 2 plus 1. So we got either x minus 2 equals 0 or x plus 1 equals 0, because something times something must equal 0, so x equals 2 or x equals negative 1. But it's got to find the stationary points, not the values for x, so I need to find out what y is. And so we got the expression up here. So y equals 12 times 2, which is 24. And then 2 squared is 4 times by 3 is plus 12. And then minus 2 times 8, that's 16. And that equals 20. So we got 0.2. 20 is one of them, and put in negative 1, we get y equals negative 12. Still going into the expression up here. Negative 1 squared is 1, times by plus 3 is plus 3, and then minus 2 times by minus 1 is plus 1, and so y equals minus 7. So the other point is negative 1, negative 7. And now I've got to sketch a curve. So like so. And 220, so 220 is that point there. The gradient is 0 there. And negative 1, negative 7, the gradient is, that's not very good and accurate. Let's put it, do a bit more to scale, about there. That's negative 1, negative 7. And we've got a negative x cubed, and that will be a positive x cubed. Positive x cubed. And so negative will do that. Negative x cubed. So it's going to have to start up here, be horizontal there, like so, because those are the two places where it's, the gradient is 0, like so. I've done that bit. Okay, and change B, going to do in red. So B, how does your sketch show the equation that has exactly 3? When does it equal 0? Well, because it crosses the x-axis 3 times. Crosses x-axis 3 times. C, let's go to green. Use a graph to show that that's, well, negative 5, if that's negative 7, negative 5 is somewhere around here. Actually, my graph is not very good, because actually if x had been 0, okay, that would be 0. So I really should have had this line. I'll put it to blue. My curve should have come through here and gone through that point there. And we should have got rid of this bit here. Okay, so it should have gone through there. See, well, that's minus 7 here. Then minus 5 is there, and going straight across there, it will hit 3 times. So I have done it. That's minus 5, and I've got 1 point here, another one there, and there. That's 3 points. That's C done, and now D. Let's go to pink. For what range of values does it have? This equals k. It's still the same expression, equal k. When's it got exactly 3 roots? Well, it's got 3 roots any time, so if k is between minus 7 and 20, because then that will cross 3 times. So the first part, exactly 3 roots, it's -7 is less than k, which is less than 20. Can't be equal to it, because equal to it, it'll have 2 roots, because 1 will be repeated. And part 2, only 1 real root, but if it's anywhere down here, it'll just cross this part of the line, and if it's anywhere up here, it'll just cross this part of the line. So it can be 2 things. K could be less than -7, or k is more than 20, and that will do. I'm a bit irritated that I didn't look at that to start off with. But hey, that's done.